Hello my dear students, here I have brought two questions from JEE Advanced 2025 paper. Okay, so these questions are from coordination compounds, okay, and which are very easy and conceptual based questions. Okay, so if you know the concepts, you can easily answer this kind of questions. So let's have a quick discussion on this with a detailed explanation. Okay, so this topic is, read the question first, the correct order of wavelength maximum of absorption band in the UV visible region for the given complexes. Yes, there are 4 complexes are given. See guys, just listen to this particular session, so you will definitely answer this kind of questions in the upcoming exams. Okay, let's have a quick discussion. Yes, 4 complexes are given. We need to arrange based on the wavelength of absorption. Okay, so whenever they are giving this 4 like complexes and they are asking for wavelength or energy of absorption, so we need to use here CFT. What is that? Crystal field theory. CFT concept we need to use. Okay, so now what happens here is, first of all, identify what are the ligands and what are the metals we have here. So in all these complexes, cobalt is a metal atom we have, metal, right? Next, what is the oxidation state of this metal atom here? So in all the cases, so here cyanide ions are there, 6 are there, -3 charge means cobalt will be having oxidation state as +3. Okay, so same complexes I have written here for just for clarity purpose, and here also it is having, see, +3, these are neutral ligands, so it is also having +3, and this is also neutral, so +3 will be the oxidation state of this cobalt, and here also here +2 and -1 for chloride ion, so therefore total charge on this complex, this metal atom will be +3. I hope you know how to calculate this oxidation states, right? So like this, we can give the oxidation state. So cobalt +3 in all the cases. Now metal atom is same, oxidation state of metal is also same in all 4 complexes, right? So now what are the remaining thing? What is the deciding factor here? Look here, the complex ligands are different here, right? So ligands are different in 4 options. Now we have in the first case cyanide ion Cn minus, and in the second case ammonia we have, yes, in the third case also we have ammonia, and fourth case we have, in one we have water and other one is Cl minus. Okay, these are the different ligands we are observing in this particular given complexes, right? Now, so the answer will be completely decided by these ligands. Now we have studied about spectrochemical series now. So what is that spectrochemical series? The arrangement of ligands based on their splitting ability, right? So what is that? Based on their splitting ability. The ligand, few ligands will be having greater splitting ability and few are having lower splitting ability. Depending upon their ability to split the orbitals of metal atom, we are arranged them. So that is what the experimental data we have now. So in that, if we see, cyanide ion is having greater than this ammonia, and then this water will be having more than this chloride ions. Now based on this, so cobalt +3, what is the electronic configuration we can write? 3d6 4s0. This is the electronic configuration of this cobalt +3 ion, right? So now I can write d orbitals in the 2 states. So let us write first of all the degenerate orbitals of this d6. 1 2 3 4 we have, and 5 orbitals I am writing here. So just look here. So these are the 5 d orbitals I have. So I am filling them like this. 1 2 3 4 5 6 electrons I have filled. Okay, so now these 6 electrons, when we place these in the ligand field, what happens? Degeneracy of d orbitals lifted. It means, so these d orbitals degeneracy energy increases. So like this we will be writing. So 1 2 3 4 5 6 electrons I have filled. Okay, so now what happens, depending upon the approaching way of ligands, these degenerate orbitals will be split into 2 different energies. So what are the different energy? One is T2G, another one is EG set, right? So we will be having like this, right? So down one, which is having lower energy set, is triply degenerated, we are calling it as T2G set orbitals, and the other one is EG set orbital. This is what the EG set orbital we are writing, right? So now this is the energy difference between them. We can say splitting crystal field splitting energy. Okay, so delta naught I am using that is the splitting energy, which is energy difference between lower energy state and higher energy state. Okay, so what are the d orbitals we have? dxy, dyz, dxz, dx square y square and dz square. like this we have now. So if you see these first three orbitals, so you will be having orbitals in between the axis. See, between x and y we have, between y and z, like this now. So this will be having one set, that is what, T2G set. Okay, so here we have dxy, dyz, dxz, like this I am writing. And the other one, the orbitals which are along the axis. See, this is along x square, it means along the x and y axis, and this is along the z axis, which is having donut shape, right? Now here I am writing dx square, y square and dz square. These are the orbitals we have. Now this is the gap. Now here how many electrons are there? 6 electrons are there now. So whenever we have strong field ligand, now what happens? This splitting ability will be very greater extent, therefore all the electrons are filled in the lower energy state only. See, we know cyanide and ammonia both are strong field ligands only with cobalt +3 configuration, therefore all the complexes given are having strong field ligand, okay, but in that cyanide ion is very stronger, right? So in all the cases, first of all we need to fill the 6 electrons in the lower energy T2G set only. So we need to fill the electrons like this, 6 electrons are filled, okay. So after filling, now for look into the question, correct order of wavelength of maximum of absorption band in the UV region. Yes, in order to show this color, so what is the reason here? DD transition we can say. So now electron which is lying in this lower energy T2G set can go from here to here, that is what the transition happens. So that's how we can observe the absorption spectra and emission spectra. Now when it is going higher energy, required from it is going from electron is exciting from lower energy T2G set to EG set, right? So now what happens? It requires some energy to excite electron from here to here. So that is what the absorption energy. Okay, so absorption energy I told you. Now every energy will be associated with some frequency and wavelength now. So this is what we will be studying now, hc by lambda. Okay, so every energy will be associated with some lambda wavelength, right? So now energy is inversely proportional to wavelength we know. So it means what we need to understand, if the splitting ability is more, if the splitting is greater extent, therefore energy gap is more, so absorption energy is required for more and wavelength will be less. I hope the concept is clear. Now I told you cyanide ion is very strong field ligand, therefore splitting ability will be more in the cyanide case. Okay, so if splitting ability is more for cyanide, it will be taking more energy to excite electron from lower energy to higher energy, right? So now E value for more for which one? So E absorption, absorbed will be more for A, then B, then C. See here in B and C, how can we decide the order? See here we have only complete 6 ammonia ligands, all are strong field, but here we have water molecule, aqua molecule which is weak field ligand. So C will be having more splitting ability than B. Therefore I should write here after A I should write C, after B, right, and after that D. Hope it is clear, because aqua molecule is greater splitting ability than this chloride ion. So that's how we can arrange them based on their energy order. So this is the order of their energies. Now wavelength means it should be opposite to this. So which is having least energy absorption, least energy absorption, D, right? So now wavelength will be highest for D here. Energy is minimum for D and wavelength will be highest maximum for the D only. So it is oppositely proportional, like inversely proportional. So which is having minimum here, so A will be having lambda absorbed, So what we should write? Lambda absorbed will be A is minimum, C is then next B, then D. Okay, so we need to take the option which is having this kind of option. So D means this one here we have, yes. After that see water molecule, yes, in the first option we have water molecule. So the next one is ammonia, yes. So this is our first option. Option 1 is correct for this particular question. I hope complete CFT is also clear. I mean the things related to this kind of concept, this kind of questions, right? So now if you want any other type of questions, and if you are preparing only for JEE level, mains level and NEET level, so you can watch a quick discussion on complete coordination chemistry. I have made a separate video so that it will be helpful, where I have included the spectral series and all. Okay, hope it is clear. Now if you have only weak field ligand, now what happens? Electrons should be filled in the lower energy as well as higher energy. But whenever we have strong field ligand like cyanide ion or ammonia, so electrons first completely pairing takes place in the lower energy state, filling of electrons takes place in the lower energy state completely, then only if any extra electron is present, that can be filled in the higher energy state. Hope it is clear, and question is also clear. If you have any confusion among this, so you can just write in the comment box. I will be clarifying it in the upcoming sessions or in the comment box itself. Okay, so feel free to express your concerns. Okay, here we have one more question which is related to practical chemistry, practical organic chemistry, as well as interlinked to the coordination complexes also. So what it is exactly? During nitroso-prusside test, sulfide ion in an aqueous solution, one of the ligand, okay, coordinated to the metal ion is converted into some, it will be converted into something. So now what we will do in nitroso-prusside test? First of all, see, we will be taking organic compounds. Okay, so generally nitroso-prusside test is used to identify sulfide ions, right, sulfur atoms. So now organic compound containing sulfur, upon treating with sodium metal, this is what sodium fusion extract we are preparing, right? So this will be converts into what? So whatever sulfur present in that organic compound converts into sodium sulfide, Na2S, right? So this sodium sulfide, Na2S, okay, so we are treating this sodium sulfide, whatever we got from the sodium fusion extract, okay, we are treating this with nitroso-prusside. So what is the formula of nitroso-prusside? So it is Na2 Fe Cn 5 times NO. Okay, this is the complex which is the formula for this sodium nitroso-prusside. Okay, so upon treating here with this, so this sulfide ion will interlink to this NO. This is what nitroxylium ion, which is ligand. So this is NO plus. Okay, so now this is the ligand which is attached to this iron metal in this complex. Okay, now it is converting into what? Na4 Fe Cn 5 times NOS. So this is how it will be converting. So NO plus is converted into NOS minus. Okay, so this is what the conversion it is taking place. So this is called nitroxylium ion, which is having positively charged. This is a ligand with positive charge, you can remember. Now what is the conversion you have taken? So you have seen NO plus is converting into NOS minus. So we have option 1. So this is a very direct question from your general notes. Whatever the notes you are following, you can see that it will be there in the discussion. Okay, whenever you are studying about, so what is that? Sodium fusion extract, there you will be seeing for identification or confirmation of sulfide or sulfur atom. So there you will be studying about this nitroso-prusside test. Okay, hope it is clear and very easy questions, right? Okay, so now I have a question for you. I hope it is clear. Now I just wanted to give you one question here. What is the oxidation state of iron? What is the oxidation state of iron in sodium nitroso-prusside, this complex, and also what is the oxidation state of iron in this final product? Okay, so you can write the correct answer, whatever you are expecting, in the comment box. I will be verifying your answer in the comment box. Okay, so thank you for watching. If you still have any confusion about these two topics, you can write in the comment box, we will discuss there. Okay, happy learning.